Okay, so you got sine, cos, and tan.
Yeah.
So that's saw, car, and toa, right?
Yeah.
And saw something really funny on Facebook about it. So anyway, if I find it, I'll send it to you.
Funny meme.
So, yeah. Oh, it's just a guy doing some comedy. Yeah, it's pretty funny. So sine.
Yeah. O over H.
Yep. What's O?
Opposite.
Yep. Over.
Hypotenuse.
Hypotenuse. Car is?
Adjacent over hypotenuse.
Yep. And what does that stand for?
That's next to the right angle.
Yep. Which trig?
Or cos, sorry. Cos.
Yep. And?
Tan equals opposite over adjacent.
Yes, it does. Opposite over adjacent. Okay, cool. So now, if you've got like a right angle triangle, right?
Yeah.
When you're doing trigonometry, we also have another angle called the reference angle, right? Which is our theta.
Yeah.
Let's do a different color, right? So the theta. Okay, and that theta goes there, right?
Yeah.
In addition to the reference angle, we have our opposite, our hypotenuse, and our adjacent, right? Now, our hypotenuse is easy to recognize. How would we recognize the hypotenuse? There's two ways to recognize the hypotenuse.
Directly across the right angle.
Yep, so it's opposite the right angle.
And it's the longest side.
And it's also the longest side. They're the two ways to recognize the hypotenuse.
Lovely.
Ways of recognizing, well, there's the other two sides, right? There's the opposite side.
Which is directly across the theta.
Yep, it's opposite the theta, right? And then the other one is our adjacent.
Adjacent.
Here. And that's adjacent means next to, okay, or neighbors with, right?
Yep.
It's neighboring the reference angle. Got it?
Lovely.
Yep. So that's that one there. And that one there, right? Now, this only works when?
It's a right angle triangle.
That's right. It only works with right angles.
Yes.
So right triangles only. Got it?
Yeah.
When we have...
Oh, this uses bearings too, doesn't it?
Sorry?
This uses
Yes, yeah, bearings.
Oh,
Yeah.
we definitely have to go over that too.
Okay, so we'll use this in
Yeah.
ways, which is bearings, right? Bearings, and the other one is elevation.
Oh, and depreciation.
Yep, and depression.
Not depression. Oh, not depression.
Yep. And we can go through some questions on that if you want.
Yeah.
But then this only works with right angle triangles. So right angle triangles will be there when we do elevation and depression, and right angle triangles will be there when we do bearings. So they'll be part of that.
Okay, that's good. Yeah.
So that's why, yeah, this kind of ties in together. But
Yeah.
there's non-right angle triangles, right? And we do this one a little bit differently, right? Now,
Yeah.
3 rules that you need to know for non-right angle triangles. Do you know what any one of those are?
Yeah, the sin cos rule.
Okay, so there's the sine rule, and that has an E on the end of it.
Sine. Yep, sine.
Yep.
The cos.
And then the cosine rule. Yep.
Cosine. That, yes, exactly. Yeah.
Yep. And then the third one, which is what we call the area
Oh, of a triangle.
of a triangle. Okay, they're the 3 rules.
Oh, yeah.
Do you remember this?
Yeah.
Okay, so apart from those 3 rules, there's nothing really more that you need to know with non-right angle triangles. However, there are this rule here, the sine rule, right? There are 2 versions of it. This rule here, the cosine rule, there are 2 versions of it.
And that's depending if you're trying to find a side or an angle.
Yes, yes. An unknown side or an unknown angle.
Yeah.
Now, applying the rule is not the hard bit. Knowing the rule and working out the rule is not the hard bit. Knowing which one to use when is the hard bit. Okay, so that's the bit I'm going to focus on and drill in for us first, and we'll go and do a couple of one question of each, right?
Yeah.
You won't have trouble with just applying the rule. Where you might have problems is which one to apply. Okay.
Yes.
So, if we were to take a non-right angle triangle, right, and I'm going to deliberately choose some different letters, right?
Yeah. Okay.
So these letters are going to be deliberately different from what you're used to seeing. You're used to seeing A, B, and C, right?
Yes.
P, Q, and R. Okay.
Yeah.
P, Q, and R are capital letters because they represent the vertices or the angles. Okay. So when we're talking about angles, we're talking about capital letters. Okay.
Yep.
And then when we're referring to the sides, right, we use lowercase letters, and the letters that we use are going to be opposite
the angle.
Yeah, the angle. Okay, cool. So what would this letter be in lowercase?
Lowercase r.
Yep. What would this letter be?
Lowercase p.
Lowercase p, yep. And lowercase q. Makes sense? All right, so this bit is the bit that I drill in, and as far as I'm aware, like I'm probably the only one that teaches this rule this way, because I made it up, okay? Because it makes sense to me, and it's made sense to most of my students in the past, okay? When do you use the sine rule, right? You use the sine rule when you've got two sides, two angles, one of which is unknown. Got it? So
two sides, two angles, and one unknown.
Yep.
Yep.
Okay. So that unknown can be an angle or
a side.
Okay. Right. So what do I mean by that? Okay. So just say we were given information for this angle, okay, for this angle, yep, but we had to work out this side. Got it?
We need two angles, two sides, because that includes the unknown, doesn't it?
Yep. Okay, so you've got two angles, or sorry, two sides, yep.
Yep.
Yep, one of which is unknown.
Okay, one of which is unknown.
Yep. Okay?
Yep.
Yep. So that's when you use the sine rule, right? So let me just go back. I don't want to go too far back. So if we had a situation now, I'm going to give you a different scenario. Tell me if we would use the sine rule or not.
Okay.
Time we'll use different color pen. So let's have a look. You got this angle, right? That angle, that side, and that side. And this time we're finding that angle.
Two sides, two angles, and one of which is unknown. So yes.
Yes, we would use the sine rule. Got it?
Okay. Yep.
Okay, now this time I'm going to do some changing.
Okay. So it's always easy when you do it in your textbook, because one chapter is for the sine rule, one chapter is for the cosine rule, and you just know which one to use. But
Yeah.
like, you've just given a diagram and it's like work out, find X or whatever, and you don't know what one to use.
So this time we're going to try and find this side. Okay?
Two angles, two sides, and one unknown. So yes.
Yep. The answer is yes. You would use the sine rule. Okay, but this one's slightly tricky because the two sides and the two angles that we need to use the sine rule for need to be opposite to each other, right? So what do I mean by that? This angle needs to be opposite that side. This angle needs to be opposite that side. Is that the case here?
No.
Right. So we've got this side and we don't have the opposite angle.
But we can work it out.
Yeah, how?
180, the angle sum of a triangle.
Yes. So if we know this side and this side, what we can, if we know that angle and that angle, yeah, then we can just work out this angle because that's the angle we need, that's opposite the unknown.
And still use the sine rule.
Yeah, and still use the sine rule, but what we do is an angle. Got it?
Yeah.
Yeah. Cool. So what is the sine rule? Okay, now the sine rule is this. And I'm going to deliberately use different letters, like I said.
Yeah.
So the sine rule, let's use mustard for this. So the sine rule is this, right? So it's either A over sine A.
A, capital A, yeah.
Yep, equals to B over sine B, which is equal to C over sine C, okay?
Yep.
Okay, now tell me, is that an angle or is that a side?
That's an angle.
Yep, is that an angle or is that a side?
That's a side.
Side or angle?
Side.
Side, angle, side.
Angle. Side.
Yep.
Angle.
Yeah, cool. All right, so with this formula, essentially what it's saying is that the ratio of a side to sine of its angle is going to be equal throughout the triangle.
Wow.
Okay? That's essentially what it's saying. For
Yep.
triangle, because it's any non-right angle triangle. It even works for right angle triangles. Yep.
Okay, yeah.
Any triangle, because a right angle triangle is also a triangle, right? So, so that'll be the case for all triangles. So when we use this, we usually put our unknown in the top left-hand corner. Yep. We put our unknown in the top left-hand corner, then it just makes life easier. Now, you won't need all three parts of this. We just write all three parts because there's three parts of a triangle and it's true for all three parts, but you only need the two sides and the two angles that you're worried about. Okay? So in this situation, what's our unknown? Our unknown is?
Little r.
Little r. So little r goes where? Little r goes?
There.
Got it? What goes there?
The angle, the big R.
Yeah, so it's big R, okay? So that's this angle.
Yeah.
Okay, what would go here?
Little p?
Yes.
Oh, no.
Yeah, because it's the side that we know.
Yes.
Got it?
Yeah.
Okay, now before I confirm that you were correct, what were you going to say? You're going to say no, it's...
No, I was going to say yes. I was going to say it is little p because we don't have the length of the little q.
Yes, that's right.
Okay.
This will be?
Big P.
Big P, right? So this formula here is ideal for working out an unknown
side.
Yes, good. Unknown side. Good. Got it?
Lovely.
Right. So if you were to use this same formula to work out an unknown angle, what would we do?
Flip it.
Flip it. Yeah, flip it. Okay, cool. So what we're going to do is maybe let's use brown. Okay, cool. So what would this formula now look like if we were to find an unknown angle?
Using our triangle or just in general?
Oh, just in general. So if we were to this formula, yep.
Sine capital A.
Yep.
Over little a.
Yep.
Is equal to sine big B.
Mm-hmm.
Over little b.
Yep. equals to sine big C
Big C.
equals C. Yep. Got it?
Yep.
Cool. All right. So I might give you a question to do.
Yep.
What have I just done? And then, cool. And you only need to use 2 at a time. Yeah.
Okay.
Yeah. Right in the corner. Non-right angle trig.
Okay. Yeah.
What chapter is it? Okay, 169.
And so if you could screenshot that again, that would be lovely.
Yeah, absolutely. Okay, I'm going to go straight to a hard one.
Yep, good.
Okay, I might get you to try. Can you see?
Yep, I can see. Yep.
Okay, 10A.
10A.
A. Okay, and then what I'll do is I'll screenshot this.
Absolutely then. Oh, cool.
Yep. Non-right angle trig. Yes.
Yeah.
Yep. And then I think there's a cool. Yep. So if you can do question 10.
Okay, yeah.
I'm just gonna get out of
Okay, sure.
second.
Beautiful. Finished.
Done. Yep. So in the Zoom chat,
Yep.
there should be I will have I think I've sent you the screenshot.
Oh, cool. Oh, that's cool. So if I just click download,
Yep.
then that's, oh, okay. Cool, done.
Done?
No, that's cool.
Good. So 4F. Let's have a look. 4F question 10A.
Yep.
4F. Where is it? 4F.
4F 10A.
10A, yep. And your answer? Did you get an answer?
Yeah, I've got 28.13.
What am
Oh.
I? Okay, hang on. So I'm looking at the wrong one.
Oh.
EF 10A 28.13.
Yes.
Ah, brilliant. Good. Good. Got it?
Yep, okay.
Probably not going to labour the point because I reckon you've got it for the sine. But I am going to go through the cosine rule now.
Yes.
Okay. Now the cosine rule we use when just rub some of this out.
Yeah. Oh my God, it's raining.
Yeah, it was. Is it raining hard? Because when I went outside, it was just sprinkling, kinda.
Yeah, it was kind of sprinkling earlier this morning, but now it's raining out. Oh my God, there's washing on the line. Oh.
Are you going to school today, or is this a school from home day?
This is school from home. So
Yeah.
that's good.
Oh, that's good.
Okay.
That's good. I like staying at home when it's raining outside.
Yes, me too.
Yeah, it's all, especially when you're all nice and rugged up.
Yes, it's so much nicer.
Okay, cool. So the cosine rule use, okay, so instead of 2 sides and 2 angles, it's 3 sides and 1 angle, one of which is unknown. Got it?
So 3 sides.
Yep.
1 angle.
Yep.
And then one of which is unknown.
Yep. So you have either have an unknown angle.
Yeah.
Or you have the side that is opposite to the known angle. So it's got to be one of those, right? So let me just explain what I mean.
Oh yeah, it's like inclusive. Like it's
Yes.
2 sides and then the angle.
That's right. Okay. So for example, if we're given 1, 2, 3 sides.
Yeah.
1 angle,
Yeah.
right? Then that sets us up nicely to use the cosine rule.
Okay.
Because we've got 3 sides and 1 angle. Now, of the unknown, it can either be the angle, okay? Or it can be the side opposite the angle. Side opposite the angle, right? So it's one side that you would be able to find if we were given this angle and these 2 sides. And that's that side here.
Yeah.
Okay?
Yeah.
If we were given that angle, you wouldn't be able to find this unknown and you wouldn't be able to find this unknown, right?
Yeah.
If you were given that side. Okay? So in other words, the only side that this will apply to is the side that's opposite the unknown angle.
Yeah.
Otherwise, you might have to use some variation of the sine rule or the cosine rule. Okay? You'd either have to find that angle and then work out that unknown side.
Yeah.
Okay? Or you have to find that angle somehow and work out that unknown side. Okay?
Yeah.
We're using the cosine rule and we're given this angle only. The only side that we can work out is
that one.
Okay? If we're given this angle only, the only side is R. Okay? Cool. So in terms of the cosine rule, there is, don't want to confuse you. What's the formula that your textbook would have used? Because there's a couple. And then there's different ways of writing it. Oh, in fact...
The A squared equals B squared.
Yeah. Okay, cool. So that's the textbook there.
Oh, I know. Yeah, okay. Well, that's to find... Let me have a look. What is this for? I don't know which one I used. 4G.
Yep.
That's Oh, we did the cos A equals B squared plus C squared.
Okay, so let's do that. Yeah. Okay.
That one's better.
Yep. Okay.
You got to square root it.
Yeah. Let's use blue. Okay, cool. So when you've got, and if you've got the cos A equals to B squared plus C squared minus A squared over 2BC, right? That one set us up for what?
Angle.
Yes, unknown angle. So let's unknown angle, right? And the formula is cosine A equals to B squared plus C squared minus A squared.
Yeah.
2BC.
Yeah.
Okay. Now, the reason why I said I don't want to confuse you is because we can write the same formula 3 different ways. Okay. So see if you can pick up the pattern. So if we start with cosine B this time, what would the pattern likely be for the right-hand side? Just following the same pattern.
Oh, just the same. Could it be A squared?
Yeah.
Plus C squared?
Would it be plus B squared? Have it?
Oh, no, plus C squared.
Okay.
Minus the B squared.
Yes.
And then it'll be 2AB.
2AB?
2AC.
2AC. Good. Right. Now, why did you choose and put the letters that way around?
Because I looked up at the
top formula. Yep.
Yeah, the top formula, and how the A is on the minus. The opposite side is
Yes. And the bottom will be whatever the other 2 pronumerals that aren't being used here are.
Yes.
Got it?
Yep.
Yeah. So good. You picked it up. Good. So if I was to go cosine C, what would that formula look like?
A squared plus B squared minus C squared 2AB.
Yes. Got it?
Yeah.
Awesome. So the reason why I say I don't want to confuse you, and now you're not going to be confused, is that people will see a situation where they see A, B, and C, right? But the letters that you put in might not be the same A, B, and C on the...
Yes, and I get confused.
Okay. It just depends on which side or which angle is unknown. Okay. So your unknown will always be your A if you're using this formula. Your unknown will always be B if you're using this formula. Your unknown will always be C if you're using this formula, right? And that would be the side opposite your unknown angle. And these would be the other 2 sides, the 2 adjacent sides.
Can you just relabel your triangle?
Okay, cool. All right, so I guess what I'm saying is, let's draw another triangle. A, B, C, right? And we're given A, B, C, okay? Now, if we were to find this unknown, right, or this angle, which formula would we use?
The second one.
The second one. Yep. If we were to try and find this one, which formula would we use?
First one.
Yep. If we were to use find this one, you'd use the
last one.
Yep, the last one. Okay. Cool. Now, if we were to try and find this unknown here, right?
Yeah.
It doesn't really matter which formula we use, right? This angle, this unknown, this P would go in the unknown position.
Okay. Yeah.
Makes sense?
Yeah.
Yeah. However, I guess what I'm saying is, if a formula sheet only gave you, if the formula sheet, only gave you the top one.
Yeah. Should be C.
But you need to find, say, this angle here, right?
Yeah.
What, even though that's A, what angle would you put in there?
C.
C, yes. You see what I'm saying? That's what I'm saying.
Yeah, okay.
Yeah. And what side would you put in there?
Little c.
Little c. And it doesn't matter about these two.
Those orders, okay.
Yeah. You can be 3 plus 4 is the same as 4 plus 3.
Yeah.
So it doesn't matter what order we do. And 3 times 4 is the same as 4 times 3. So it doesn't really matter about these two. Right?
Okay.
They're not as important getting the order right. As long as you got this right and this right, the rest of the formula will work. Got it?
Yeah.
Okay, so that's an unknown angle, right? And when it comes to an unknown side, okay, so unknown side this time, then you've got a different formula, and the formula looks like this. A squared equals to B squared plus C squared minus 2BC cosine A.
Yes, okay. This is rearranged.
Yep. Okay, cool. So if you rearrange this so that B is your unknown this time, what would it be?
C squared.
Yep.
Or A squared plus C squared.
Yep.
Minus 2AC.
Yep.
And then cos B.
Yes. Got it?
Yeah, okay.
Cool. C squared equals?
A squared plus B
Yep.
squared
Uh-huh.
minus 2AB
Yep.
cosine C.
Yes. Got it?
Yeah.
Yep. Yeah, so that's really good. The only other thing I would say is
Yeah.
with the sine rule, right? Just be aware that if you've got an obtuse triangle, right, or obtuse angle triangle,
Yeah.
what I mean by obtuse angle triangle.
Larger than 90.
Yes. Okay. So if you, but less than
180.
So if you've got an obtuse angle triangle, right?
Yeah.
And if you put this in your calculator and you get an angle, it's going to give you an acute angle.
Oh, yeah.
So then you've got to find its supplementary. You've got to take it away from 180 in order to find what the obtuse angle is.
So you put it into your calculator and will the number be,
An acute,
the number will be acute.
yes. Okay. So then you've got to go, oh, hang on a tick. I can't just rush straight in and put the answer in. I've got to look at the triangle and see whether it's an obtuse triangle or an acute triangle, because the calculator will only give you the acute triangle.
Okay.
Yeah.
So that one that you gave it in the black, that triangle on the black, that's an acute.
That's an acute. Yeah, probably. Let's until we're told in the question that it's an obtuse triangle.
Okay.
I don't know. Yeah, but they might say, for example, like this might look like Q might look obtuse, and if the question says Q is an obtuse triangle, right?
Yeah, okay.
The angle Q is an obtuse angle, right? Inside the triangle PQR, work out what Q is.
Yeah.
The calculator will give you the acute angle.
Yeah.
And then you've got to read the question and pick up on the fact that it is obtuse.
Yeah.
And so take it away from 180
Yeah.
to give you the obtuse angle, right? But if they give you an obtuse angle,
Yes.
so if they give you an obtuse angle and you've just got to find an unknown side,
Yeah.
then just use the obtuse angle. There's nothing you need to do to change it back. You don't need to change it
So if
to
it's already obtuse, you just keep it.
Yeah, if it's an obtuse angle that we already know, then just keep that angle and put that angle in the formula.
Yep.
Out in the wash. But if you're going in reverse and finding what the obtuse angle is,
yep,
it'll only give you the acute angle, so you need to take it away from it.
Okay.
Okay. Now, when it comes to the cosine rule, it's a little bit slightly different, right? So for a cosine rule, okay, what will happen is it'll give you a negative answer if it's an obtuse angle.
Yep.
Then what you do is you add 180 to it. Okay. So if your answer ends up being minus 40 degrees, right? What would you do to that to find the angle that you're supposed to find?
Add 90?
Close. Add 180, and that will give you the obtuse angle. So do you have a calculator with you now?
Yep.
So take that minus 40.
Yep.
Because that could be an answer.
And add 180.
And add 180.
140.
Yep. Okay. So whenever you get a negative angle for using the cosine rule, just add 180 to it.
Oh, add 180. Okay.
Yeah. And that'll give you the cosine rule.
And that would give you the answer.
It'll give you the obtuse angle.
The obtuse angle.
Yeah.
Oh, I remember this now.
Okay. So they're probably the two tricks.
So if it's sine,
Yep.
you have to minus
From 180. Yep.
from 180. And if it's the cosine,
And you get a
negative number, you've got to
Yep.
add 180 to get
Yes.
that. Okay.
Yes.
Okay.
Okay.
And so it's just depending on the triangle that they give you and the question.
Yes.
Yeah. Okay.
Yeah.
Okay, well that's good. Screenshot that definitely too.
Okay. I haven't really kind of put that in the screenshot. Like I haven't actually kind of given you an explanation of that so much. Hang on. I'll do that over this side.
That's okay.
Cool. So basically, obtuse angles.
Yes, okay. I think because we talked about it, even if I just look at that, I'll know what we're talking about.
Yeah. Now, what I was going to say is if I recorded some of these lessons and gave you a copy of it, would you be okay with that?
Oh, yeah, of course.
Yeah. So that way, you can look back on it and have a copy, and if you get stuck and you're like, oh, yeah, I remember someone saying something about that.
Yeah, that's cool, actually. I would like that.
Yeah. Okay, cool. Yeah. So I'll send that to you in the chat as well.
Okay, sure. Easy. Oh, there you go.
Thing we're going to do for non-right angle trig is the area of a triangle. Got it?
What was that, sorry?
Sorry, the area of a triangle.
Area of the triangle.
Yeah. And area of a triangle is really quite simple, okay? You just have to remember the formula. Oh, you actually don't. You don't even have to remember the formula.
Yeah.
Because I think the formula is in the reference sheet. Okay, and for the area of a triangle, it's just
What a half times something.
yeah. So the normal area of a triangle is half base times height.
Yeah.
Okay. But if you don't have the perpendicular height, but you do have two sides and the included angle, then it's half A times B, half the two sides multiplied together,
Yeah.
times the sine of its included angle.
Angle.
Okay. So if you've got a triangle like this,
Yep.
and you've got A, B, and C, okay, and you've got this angle here. Yep.
That's big C.
Yep. So it's half AB sine of the included angle. Got it? So if we've got this side that we know, this side that we know, which angle is the included angle? It's the one that those two sides make.
Yeah.
That angle there, that's your C. Got it?
Yeah.
Okay, so if I were to give you an example of this.
So that'll be if the question asked you what is the area of the triangle.
Yes, that's right. So, for example, let's have a look. Okay. Can you find the area of this triangle?
Yeah. Do you want me to put in my calculator and say it out loud?
Yeah, well, yeah, tell me out loud.
Okay, yep.
And then we'll put in our calculator and check.
Okay, so it'll be half times 15.
Yep.
Times 20.
Yep.
And then times sine. Is it always sine?
Yeah, always sine.
Okay. Sine 90.
Yeah. Got it?
Okay.
And you can put that in your calculator and tell me what you get.
Times sine 90. 150.
Yep, 150.
Okay, lovely.
Awesome.
So it's always sine. Why is that?
It's always sine. Why is that?
Yes.
Okay. The answer is...
Because it is.
The answer is because it is kinda.
Yeah, okay.
So basically, remember how I said to find the area of a triangle, it's half base times height?
Yes.
Yep. Okay. So I'll show you how we get this formula here, right? That's the perpendicular height. Imagine that is the base, and let's call that base A. Okay. And let's say that's a right angle triangle.
Yeah.
And we've given this side here, right? That side there. And that side's B. Got it?
Yeah.
And then that included angle is theta, right? What's another way of showing the height? So the height is going to be...
Oh, that would be...
Theta is equal to H on B.
Yes, yes.
Right? So opposite over hypotenuse.
Yeah.
Right? By the time we rearrange it, the opposite, which is H, is going to be B sine theta. Okay? Because we multiply both. Just take this B and bring it up over here.
Yeah. H is
B sine theta.
Sine theta.
Yep.
Yeah.
And so if we're using half base times height, it's half the base times the height, because the height is B sine theta.
Yes, okay, that makes sense.
Got it? Yeah, but you don't need to know that. Just know that that's how we get the formula.
Okay, that's just how what? See.
Yeah.
Okay, that's good.
Yeah.